Today I want to look at geometric series and whether or not they converge or diverge. Now, what exactly is a geometric series? Now, we'll have a geometric series if we have some starting term, some constant, right, which we'll call A, which is constantly being multiplied and added by some ratio. So let a geometric series, and we'll call our ratio R. So our geometric series would start off with just A, and then we would add A times, so A is our constant term, times our common ratio, right? And then we'll say plus A times R squared plus A times R cubed plus dot 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 all the way up until whatever number. So we'll say A times R to the K, right? And K can be some huge number, whatever we want it to be. But this would be the format of a geometric series. Some start term A multiplied by some common ratio R, right? Now, let's look at our example right here. 5 plus 5 halves plus 5 fourths plus 5 eighths. Is this a geometric series? Well, we can clearly see that our start term A is going to be 5 in this example, right? So we'll say, here we go. We've got 5 is going to be equal to A. Now, what about R? What would our common ratio be? Now, it looks like for this term right here, we're multiplying it by 1/2, right? And then this term is being multiplied by 1/4. It turns out that 1/4 is 1/2 squared. And then this one's being multiplied by 1/8, which so happens to be 1/2 cubed. So it looks like we found our common ratio, right? It looks like R is equal to 1/2. Now, how can we find out if this series converges or diverges, right? Well, this is an infinite sum, right? So we're going to write this in summation notation. If you don't really know what summation notation is, you're not familiar, there are videos out there you can look up. It's really simple to understand. So we're going to rewrite this, right? We're going to write this as the sum, right? There's my sum. That is a horrible sum. From k is equal to 0, that's where we're going to start, and we're going to go to infinity, right? And how are we going to write this? We are going to write 5 times 1/2 to the k, right? Now, if we plug in any number for k from 0 to infinity, you'll see we'll get the parts of our sum. When k is equal to 0, we get our first term over here. When k is equal to 1, we get our next term. 2, this term. 3, this term, right? And we add them together. That's why it's called a sum. Now, we have our series written in summation notation. What does this converge to? Does it converge? Is it equal? Well, if it does converge, right, we're going to say that our answer is going to be equal to A over 1 minus R, right? That's what it's going to be if it does converge. Now, does it? We say that this geometric series will converge if our common ratio, if the absolute value of our common ratio is less than 1. And as it turns out in this example, last I checked, the absolute value of 1/2, which is just 1/2, oh, I don't know why I wrote this equals, just forget about that, is indeed less than 1. So our series does converge, we have found that, and so now to find what it converges to, we're just going to use our little formula right here, A over 1 minus R. Now, remind me, what is A again? A is just going to be 5, right? That is our starting term, our constant, over 1 minus our common ratio, 1/2. So this is going to be equal to 5 over 1/2, which is just the same thing as saying 5 times 2. And our series converges at 10. That is how we find convergence or divergence if our ratio is not less than 1 for a geometric series. If you made it to the end of this video, thank you for watching. I really appreciate it, and I hope you learned something.